Hello everyone, today I will show how we can use delegate call to attack a contract using storage collision attack. So first of all, I want to show how call and delegate call function attacks in Solidity. So this is a contract called callee where we have a single variable x and we have a function set x to set the variable. Then we have another contract caller what have two different types of variable. One is same as the callee, that is x, and we can store the address of callee using this function. So we can set the callee using this function. Then we have two different functions. One is call set x and another one is delegate call set x. So this first function is calling this callee contract using call, and it's using this set x method and updating the x using this argument over here. And delegate call is doing the same thing over here. It is using this delegate call method and using the same function to update the value of x. So let me deploy these functions first. So I want to deploy callee and deploy caller. So first of all, I want to set callee. So I want to copy the address of callee and update this. Then at first, you can see both of the x from the both contracts is 0. So first of all, I want to use this call set x function. Let's say 1. And when I press this, the x from callee, it is updated. And the x from caller is not updated. So we are updating the child contract. Okay, so let's use the delegate call function. Let's the 5 over here, and if I press this button and check x from callee, it's not updated, but instead the x variable from the caller is updated. So what we have learned over here is that we can use call function to update something to the child contract. But whenever we want to update our own contracts variables value, in that case we can use delegate call. So it is just like using a third party contract to update our own variables value. So now I will show how we can use this delegate call functionality to attack a particular contract. So first of all, I have a contract that is called proxy, and in this proxy contract we have three different variables, that is x, owner, and logic contract. X is used for storing a uint type variable, uint type value actually, and owner is used for storing the owner of this particular contract, and logic contract is used for storing the third-party contract address. So in this constructor, we are setting the logic contract address and the owner. And in this second function over here, we can actually update the logic contract. So a owner can only update the logic contract address. Okay, so it is basically means we are using a pattern called proxy pattern, where we can update the third-party contracts to change the logic of a particular contract. So this proxy contract can actually update its own functionality. So basically, we use fallback function to use this proxy pattern, but for our use case and to make it easier, I have created two functions over here. One function is calling a function called increase x using delegate call, and this function is using delegate call functionality to call a function that is called set y. So these are two functions that we're gonna use. So first of all, I want to show our first logic version 1. This is a very simple function where I have one single variable x, and we can use this increase x functionality to increase the value of x by 1. Then I have our second logic. Here I have two different types of variable. One is x and another one is y. The difference between this function is that it is updating the value of x by 1, but in version 2 we are updating the value of x by 5. And we have another function that is set y that it can be used to set the value of y. So now I want to deploy these functions. So let's deploy logic version 1 and logic version 2, and I want to deploy proxy with the address of logic version 1 for now. So let's paste it and deploy. So as you can see over here, the value of x is 0. The owner address is my address, that is this account's address, and logic contract address is this address, that is this particular logic version 1's address. So let's use this delegate call increase x functionality. So I press one time and it will increase the value of x by 1. Let's press this two times and the value should be 3. Okay. As a logic version 1 doesn't have any set y functionality, so we are not going to use this. Let's upgrade the logic using our proxy pattern. So I'm just copying the address of logic version 2 over here and upgrade it. Okay, so now if I use this delegate call increase x function, that will actually call this increase x of this logic version 2. So in that case, x should be increased by 5. So let's press it one time and the x should be 8 now. So as you can see, our new logic is working. So let's set x, let's call this particular function set y. Let's set 1. So if I call this, so before calling it, I want to show what is the owner address. So as you can see, the owner address is same, but when I click this, at the same time I check the owner address is changed, even if we haven't touched anything from here. So the value of y is set and the owner address is also changed. So why is that? The thing is, we have 3 different variables over here and EVM creates 3 slots for those. So these are 3 slots and each variable is stored on a particular slot. So x is stored on the first slot, owner is stored at the second slot, and logic contract, it is stored on the third slot. So whenever we are using logic version 2, that is actually messing up with our proxy contract. So in our proxy contract, we are accessing the first slot using x, but whenever we are updating y, that is actually referring to the second slot of the actual proxy, and that is owner. So whenever we are updating y, that is reflected as owner on the actual proxy contract. So that's why it is happening. So a attacker can use this loophole to update the variables on the actual contract. So we need to be very careful about this. So what is the remedy? How can actually we can get rid of this attack? So I have another contract that is logic version 2 fixed. So what is the change over here? The change is that we just copied all of the variables that is declared on proxy, and then we have declared our local variable over here. So we have defined all of these variables and we have another variable y. So let's try it now. So first of all, I want to deploy logic version 2 fixed, copy the address, then I want to deploy this proxy using our updated logic. Then First of all, we have 0, we have owner, we have logic contract. Let's use the increase x functionality. So it is using 5. So we are using this function, and let's update the value of y now. So if I press this and check the owner now, as you can see, the owner address is not updated now. So our function is now secured. So this is how we can actually make the logic secure while using delegate call functionality. And later I will show different patterns. Keep tuned. Thank you.